In this video, we're going to take a look at a couple of applications for integration, for indefinite integration. So in this first one, we've got a rate of growth of a population of a new city T years after its incorporation is estimated to be given by that function. If the population was 5,000 at the time of incorporation, we want to find the population 9 years later. So just like any other word problem, we want to make sure that we're approaching the problem with the right technique. If you're in the integration section, of course, you're going to be gravitating towards doing an integration, but we need to know why this is an integration problem. So when you get to your final exam and all the word problems are all mixed up, you know what technique to approach the problem with. So we know that for a derivative problem, that we know we need to take a derivative if we're being asked to find a rate. So in this problem, we're not being asked to find a rate, we're actually being given what the rate of growth is. So it's this fact that we are given a rate and we want to go back to the actual population. So we don't want to compute another rate, we want to go back to what the actual population is. Then thinking about calculus, this is giving us a derivative and we're wanting to go back to the function. So it's that sort of idea that tells me this is an integration problem. So make sure when you're working through your homework, you're identifying why it's an integration problem before you just go and start integrating. Okay, so since we do know it is an integration problem, what we're wanting to do is figure out what that original population function looked like if we know that the rate of growth is given by that function in the problem. So we want to find that big P of t. So to do that, we want to integrate this rate. So we're going to integrate 300 plus 600, and instead of writing the square root of t, I'm going to write that as t to the 1/2. And we want to integrate this with respect to the variable that's there. So my notation here would be dt, because I want to integrate that with respect to that variable t. Okay, so let's go through and integrate this. So our constant rule for integrating 300 would be 300 times my variable t, plus power rule here is my coefficient divided by my exponent plus 1. So 1/2 plus 1 means I'm dividing by 3/2 times t raised to that old exponent plus 1. So raised to the 3/2. And then even in word problems, anytime we do an indefinite integration, we need that plus c, our constant of integration. So let's clean this up a little bit. So we're going to have an overall population function that is 300t plus, let's see, 600 divided by 3/2 is the same as 600 times 2/3. So if we divide that 3 out and multiply by 2, we get a coefficient of 400, t to the 3/2 plus c. So here is the function whose derivative is this. So we're going to use this population function to answer that question about what the population is 9 years later. So we know that this function currently has two variables in it. It has t and it has c. So we need to figure out what that c is before we can evaluate this function for that particular time of 9. So there's got to be some information given in the problem that's going to allow us to replace that variable c with what c actually is. So we know from this problem that the population was 5,000 at the time of corporation. So we know that at time 0, the population was 5,000. So we know that if we plug in a 0 for t, that we end up with 5,000 for our answers. So if you think about that, if I replace 0 for my t's here, and to get 5,000 for an answer must mean that my c is equal to 5,000. So now we've got a formula that will only contain my variable t. So we can replace this now as, or write this now as p of t is equal to 300t plus 400t to the 3 halves plus 5,000. So there should always be some information in word problems and application problems that allow you to figure out what that C is. So typically you're given a full point. Like here we were given the full point, T is equal to 0 and P is equal to 5,000. And if you replace those values in for those variables in the function that you have at this stage, you should be able to solve for C. Okay, so now we can evaluate the question, which was to figure out what is this population after 9 years. So that means just replacing all of our time values or all our time variables with 9. So I'm going to have 300 times 9 plus 400 times 9 to the 3 halves power plus 5,000. So handy dandy calculator time, and I end up with 185,000. And since this is an actual population, then my label or my unit would be people. So in 9 years, this particular community will have 185,000 people according to that function. Okay, let's take a look at another example. In this problem, we are being asked to find a function whose tangent has a slope of 5 minus 4x for each value of x and whose graph passes through the point 1,7. So again, let's think about why this is an integration example. So in the past, we have been asked to write the equation of a tangent line. And in this problem, we're given information about that tangent line. So in this problem, we have been given slope of the tangent line, and we want to go back to the original function. So think about what you've been given and where you want to go. So if you write this down, like on the exam, when you've got all of these mixed up, write down what you have and where you want to go, and then you'll know whether you're going from a derivative back to the original function or whether you're going from a function to a derivative. Because we know that the slope of a tangent line is definitely a derivative, and we want to go to the original function. So in order to go from a derivative to an original function, that means we need to integrate. So to find that original function, we want to integrate this known derivative. And that known derivative was the slope 5 minus 4x. And we want to integrate that with respect to that variable x. So if we integrate, constant rule, so the integral of 5 is 5x. Power rule here, so coefficient over exponent plus 1, and then my constant of integration. So we have our function right now as 5x minus 2x squared plus c. So you should always be able to get to this point here for your function. So that's your whole family of functions. But we want to get real specific. We don't want that constant to be a generic constant. We want to know exactly what that c equals. So remember, you should always be given enough information in the problem to find that. You should be able to be given or be able to find out a point to plug in, an x value and a y value. And of course, in this problem, that's provided in the form of a point. So back into our function here, we're going to replace that information. So the point we were given was 1, 7. So we're going to replace the 7 for y and the 1 for x, and then that should be enough to tell us what c is. So we've got 7 is equal to 3 plus c, so our c value is 4. So that means the answer to the question is the function is equal to, and I'm going to reorder this and put this in decreasing order. So I'm going to put my squared term first, minus 2x squared, followed by my first degree term of plus 5x, and then my c, which we just figured out was 4. So there's the function that has that particular given slope at that particular point.